You think you comprehend time, you wear a watch, you sense that you are growing older, you recall yesterday and you plan for tomorrow. Time appears to be clear. It appears to be the world's most natural thing. It's not time though. That's only a sense, a biochemical deception your brain plays on you. Most people walk around with this beautiful idea in their heads that time is a river. You think it flows, taking you along from the past, through the present, and into the future. You think it moves. But here's the trouble with that wonderful image. If time is a river, how fast does the river flow? 1 second each second. That's meaningless. That's like stating a table is 1 table long. It informs you absolutely nothing about the nature of reality. In all honesty, the truth is far less romantic than a flowing stream, far stranger, and much more mechanical. Time doesn't flow. Time doesn't force you somewhere. And if you think you have a decent hold on how time works just because you can count seconds in your head, you're in for a pretty nasty awakening. The confusion starts in your brain, so let's start there. You think your internal clock is a dependable instrument. It isn't. It's a tangled mix of translation schemes. Consider a simple experiment. Try to count to 60 seconds in your thoughts. Just sit there and count 1, 2, 3. You believe you're recording time, but what you're really doing is executing a very unique, very personal software. Some of you, when you count, you hear a voice in your head. You're physically speaking to yourself, sub-vocalizing 1, 2, 3. If someone interrupts you and asks you to talk, you lose your count. The machine jams. But others, and this is where it gets intriguing, don't hear a voice at all. They see images. They might notice a tape measure with numbers on it clicking by like a ticker tape, click, click, click. You can actually check a laundry list or read a newspaper while counting time if you use that visual tape measure system. You can sort your socks, look at patterns in the weaving, and still maintain that mental tape measure ticking precisely. But the person who counts with a voice, they can't read a word without losing track of the time. This tells us something basic. Time, as you perceive it, is merely a mental construct, a game of pattern matching that your brain engages in. It varies wildly from person to person. It is not a constant that applies to everyone. It's a biological hallucination. Therefore, you have to set aside your brain when discussing physics and the universe. We have to stop talking about how it feels and start talking about what it actually is. That in physics, we have to be operational. That means we don't ask what is the essence of time, because that's a question for philosophers who enjoy arguing over coffee. We ask, how do we measure it? And the answer is almost disappointingly easy. Time is just a way of ordering events. That's all. It's a labeling system. Imagine you have a deck of cards. You lay them out in a row. You can say the jack is before the queen and the king is after the queen. The cards aren't moving. The table isn't flowing. The order is just a structural property of how the cards are arranged. Time is the table. Events are the cards. We are simply reading the cards from left to right when we say that time passes. This brings us to the biggest mistake everyone makes. You consider time to be a container. You picture the cosmos as a large, empty box. And time is a ticking clock on that box's wall. Even if the box is empty, you think that if we removed all the stars, all the planets, all the atoms, and all the light, time would keep ticking, tick, tick, tick. Wrong. This is the Newtonian view, and it's dead. Time is not a background stage. Time is a measure of change. Time stops if there are no changes in the universe. No atoms vibrate. No light moves. No energy shifts. It loses its significance. You cannot define a second without a physical process to mark it. A cesium atom oscillating, a quartz crystal vibrating, a swinging pendulum. Time is not separate from the stuff in the universe. Time is a property of the stuff. This is where your intuition fights back. You're saying, okay, but surely time acts on things. Time makes me get older. Time causes the milk to spoil. It doesn't. This is a linguistic trap. Time is not an agent. There are no hands in time. It doesn't get into the refrigerator and ruin your milk. Bacteria do that. That's what chemical reactions do. Entropy does that. Time is just the bookkeeping system we use to track the rate at which those reactions happen. It's like saying inches built the house when you say time did it. Inches didn't build anything. Carpenters did. Inches just tell you where the walls are. Time, not the worker, is the ruler. Let's push this ruler analogy further, because this is where things get really weird. What happens if time is merely a flexible ruler that we use to gauge the separation between events? This isn't science fiction. This is measurable fact. In the past, we believed that a second was the same everywhere in the universe. It seems obvious that a clock on Earth and a clock on Mars would tick in perfect unison. It feels right, and it's completely false. The rate at which clocks tick depends on where they are and how fast they're moving. This isn't a clock malfunction. It is a fundamental feature of reality. Consider yourself operating a vehicle on an enormous flat piece of paper. You can drive north or you can drive east. If you drive purely north, you're making maximum progress in the northward direction. But if you turn the steering wheel and start driving northeast, you're sharing your speed. You are traveling a little bit east and north. You aren't going north as fast as you were before because you diverted some of that motion to the east. Now replace north with time and east with space. This is what relativity is all about. You are always traveling at the same speed across the cosmos, but that motion is shared between space and time. If you sit perfectly still in your chair, you're dedicating all your motion to moving through time. You are moving at the fastest possible speed, 1 second per second, into the future. But the moment you stand up and walk or get in a rocket and fly, you're diverting some of that motion into space. You're moving through space, which means you mathematically must move slower through time. Your clock slows down, your aging process slows down, you aren't breaking the machine, you're just changing direction on the map. You would use all of your motion for space if you could travel at the speed of light, which is the universe's fastest possible speed. There wouldn't be any motion left for time. For a photon of light, time does not pass. It is born and absorbed in the same instant from its own perspective. The universe is frozen. Well, I don't feel my watch slowing down when I run for the bus, you may be thinking. Of course not. You're too slow. You're a biological snail. The effects are tiny at human speeds, but they're real. We have to program satellites with this math. GPS satellites travel quickly. Thus, their time is not the same as your time, and we literally have to adjust their clocks. If we didn't, your GPS would be off by miles within a day. We are tricked by another aspect of time, which is related to the counting problem, the concept of pattern recognition. We perceive time as having a direction, an arrow. Past is fixed, future is open. You can remember breakfast, but you can't remember dinner. Why? If physics equations work forwards and backwards, and most of them do, why can't we remember the future? If you film a planet orbiting a star and play it backward, it looks perfectly fine. It obeys all the laws of gravity. However, everyone can tell it's fake if you record an egg breaking as it falls to the ground and then play it backward. The yellow yolk doesn't leap off the floor, assemble itself into a ball, and seal itself inside a shell. Here's the secret. This isn't about time itself. It's about probability. It's about disorder. It is much, much easier to break an egg than to build one. An egg can be broken in a billion different ways. Scattered here, splattered there. Shell in 3 pieces, shell in 1,000 pieces, but there is only one specific arrangement where the egg is whole. So as things move and interact, they naturally stumble from the organized state, few options to the disorganized state, many options. We call this entropy, and this is the only reason you feel an arrow of time. You're watching the universe shuffle the deck of cards. You started with a perfectly ordered deck, and every second that ticks by is just the universe shuffling it a bit more. You can't unshuffle the deck just by hoping. This implies that your perception of time passing is merely your brain's way of noticing how messy the universe has become. You're a disorder detector. When you distinguish the past from the future, you're really just distinguishing less messy from more messy. Your brain wouldn't be able to distinguish between the past and the future if the universe were in a state of maximum mess, maximum entropy, where everything was dispersed equally and nothing fascinating was happening. There wouldn't be an egg to crack. There would be no memory to form in a thermal equilibrium universe. The arrow of time vanishes. So let's go back to those people counting in their heads, the ones seeing the tape measure versus the ones hearing the voice. They're both struggling to impose a rigid linear structure on a universe that is actually much more flexible. Because we must survive, we create these mental models, these counting machines. We need to know when the harvest is ready or when the tiger will arrive. We evolved to track duration, but we did not evolve to understand the dimension of time. Our brains are efficient, not accurate. We focus on the now because that's where we live. But in physics, now is a very slippery concept. Our current situation is essentially the same if we are standing next to each other. But if you're on a planet 1,000,000 light years away and you start walking away from me, your definition of now slices through the universe at a different angle than mine. What you consider to be happening right now might be in my future. What I consider right now might be in your past. These days, there isn't a universal that encompasses the entire cosmos. The universe is a 4-dimensional loaf of bread, a block of events. And your speed determines how you cut that loaf. This is difficult to understand. It feels wrong. It feels like I'm telling you that up is down. But that's because you're trying to translate the high-level language of the universe into the low-level language of your biology. Instead of measuring light beams, you're attempting to count socks. When you try to force the universe to fit your intuition, you get confusion, you get paradoxes. But when you let go of what you think time is, when you stop trying to count it like a pile of laundry and start measuring it like a dimension of space, suddenly the equations work. Suddenly the universe makes sense. We're not done, because even if we accept that time is a dimension and that it stretches and squashes with speed, there's a much deeper question lurking at the bottom of the well. We have discussed the arrow of disorder and time measurement, but we have not yet discussed the beginning. If time is a measure of change, what happens when you run the movie backward all the way to the first frame? If the universe is expanding and we wind it back, it gets smaller and smaller, hotter and hotter. Eventually, you hit a point where the laws of physics themselves start to melt. You see all our clocks, our atoms, our planets, our light beams, they exist inside the universe. But does it make sense to wonder what transpired before the universe itself was created in what is known as the Big Bang? This is the ultimate test of your new definition of time. If time is just a way of ordering events inside the universe, then asking what happened before the universe might be as nonsensical as asking what is north of the North Pole. In terms of grammar, the question seems reasonable, but in terms of geometry, it is nonsensical. Beyond the North Pole, there is no north. Time might not have existed before it started, and yet we still have that nagging feeling, that internal counter, that voice counting 1, 2, 3. We desperately want the universe to have a backstory. We want a timeline that stretches back forever. It's difficult to believe that the counting machine had an on switch and that the tape measure might just start. This creates a friction between our psychology and our cosmology. We are finite beings trying to comprehend the infinite using tools made of meat and electricity. It's a wonder we understand anything at all. Consider the patterns again. The person who sees the tape measure in their head can count while reading because they're using different circuits, visual versus verbal. Physics is the same. Classical mechanics was the verbal counting. It worked for day-to-day stuff. Relativity is the visual tape measure. It allows us to process complex patterns that the old way couldn't handle. We're constantly upgrading our mental software to match the hardware of reality, and the upgrade process is painful. It requires discarding ideas we love, like the river of time. But here's the beautiful part. It works for you despite the fact that your internal clock is a biological hack, your intuition is incorrect, and time is not a rigid metronome, but rather a flexible, relative, bendy dimension. You can still boil an egg. You can still meet a friend for coffee at 2 p.m. The weirdness of relativity is hidden under the hood. You don't need to understand the combustion engine to drive the car. Furthermore, it is not necessary to comprehend space-time metrics in order to function in daily life. But isn't it better to know? Isn't it better to know that the engine is there? This brings us back to that strange experiment with the counting. Remember the difference between the person who hears numbers and the person who sees them. This is not just a party trick. It exposes a horrifying gap in our knowledge of the cosmos. When two people talk to each other about something complex like time or relativity or love, they think they're speaking the same language. They give a nod.